Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Shankleberg.
And I'm Philip Sage with the Manaway Group in Australia.
Hey, Philip. Good talking to you again. I know the last time you talked, you had a little craggy throat, so I'm hoping that's feeling better and all that works out for you. You got to stay off of airplanes or something. I don't know. But anyway, sounds like you're staying busy with work and all that other good stuff. But hey, we were chatting, kind of about what to talk about this time. And in our last discussion, I mentioned the shiny object thing, and we listed like in IIOT and digital twins. And I'm sure if we thought about it, we come up with 5 or 6 or a dozen more fads that have come and gone in the world that affect, asset management, reliability engineering and stuff. But you also mentioned in a little bit about, as we're thinking about this one, is something I've never run across before, never seen before, is high precision planning and then high precision maintenance. And I'm like, is that a fad that I missed? But it sounds, and so I'm really interested in what that is and where'd that come from? And, and it's mostly just, I'd never heard it before.
They're great topics, and they've come out of industry in a particular industry vertical, and the emphasis on the precision aspects of maintenance and planning, in particular, to achieve maintenance, are fundamentally driven by the proof that if they maintain their assets with precision, that the first pass quality improves by 250% in that particular factory. And the concepts of HPP, or high precision planning, that supports high precision maintenance, or HPM as it's known, or coined by, are driven in conjunction with the lean methodologies, where you target waste and attempt to remove the variability of the way that technicians do maintenance, so much so that your goal is that every technician does the job the same way every time. And by doing it that way, every time, you are, of course, hopefully doing it the correct way, but you're removing the variability, which then leads to the machine-induced quality failures that are so prevalent in many industries, in manufacturing, being removed, or at least significantly reduced, to the point that the first pass quality and, as a result, the productivity increases, because you have removed the prototypical failure modes from the process.
Well, so let me just put an example on this, see if I understand this. And from a statistician's point of view, it's like, well, let's get rid of the variability. And it's part of it is, like, for example, if you're aligning a motor on a shaft to something, right? You're connecting a motor to something. I know that alignment matters. In my experience, I don't think I've seen 2 technicians approach that the same way ever. In my experience, and even the same technician with a slightly different motor structure will do it in a different way. I did, in hindsight, I know that, and talking to people that, sell the service of motor alignment and tools to do it and so on, there is a right way to do it, and there's really bad ways to do that. And I think I have happened to experience a lot of just haphazard ways to do it. But so what you're talking about is a high precision maintenance was that your whole team would have the same procedure basically and methodology, and would actually do it the same way when they're in the field, when they're working on the equipment. And by doing so is that even if it's not, say, perfectly aligned, if we're all doing it the same way, it'll become obvious what part of that process that we need to adjust or fix or update or whatever, so you can get on target. Versus random, then we have lots and lots of noise. We have failures for all kinds of different reasons, and because we have all these different sources of problems that affect the alignment. Am I on target for what you're talking about with high precision maintenance?
Yeah, I think you're absolutely on target with a very good example that will resonate with a lot of listeners. And let's just pick on a prototypical motor change where you have to change the motor and provide at least some part of the coupling, presumably, and do a shaft alignment, trying to get that down to near 0, or within the tolerances. That's its own whole animal for precision, and it really research has proven from the Thermographic Institute, I think it is, in North Carolina years ago, with the Miller report, that the precision at which you achieve the shaft alignment and angularity and offset absolutely matters based on the type of coupling that you have coupled between the two areas. Mm-hmm. But absent of the precision, let's talk about the high precision planning aspects. Obviously, to plan a shaft alignment for a particular coupling in your or a motor coupling group in your factory, you need to write it down. There has to be a written plan. And most importantly, we say, okay, one of the reasons we have intense amount of variability with the many different people that do shaft alignment is that we send them out there without a plan. So what aspects would be important as part of the plan? Well, we're going to encounter base bolts. We're going to need shims underneath the base bolts, and those shim kits have to be available. And what I found in practice is that they're not often available. The box that they originally came in is available, and it's often got a haphazard residual amount of foot shims in it. But what we want to do the job in a high precision environment is we want a full box with all the right shims in it as part of the plan being provided out to the job. But most importantly, each of those base bolts, we need to understand what torque that we're going to apply to those. We have to have a torque wrench. In a high precision planning or high precision maintenance environment, technicians actually calibrate their torque wrench on the way out of the work area every morning. It's a very unique concept, but we're trying to ensure that those base bolts, whatever the locking washer, I would propose Nordlock is probably a pretty good one based on the Junkers testing out of the University of Michigan, that we're trying to make sure that those base bolts are cinched down to a certain amount of torque and precision. And in order to achieve that, we have to specify what that is. And ideally, from a tools perspective, what torque wrench, what socket size do we need in order to do the job? And from an alignment perspective, of course, what's the tolerance for this specific type of coupling? And that's a very important aspect in the practice of precision maintenance, is that all couplings are not the same. Yep. And that we need to, especially on grid flex couplings, for example, we need to be within a couple mils in the English unit system.
Yeah. No, I can see an ops manager going, wait. What are you talking about? I need to hire 5 more planners that have experience with all this stuff. They can write all this stuff down. Just give me one technician and torque wrench and they're off. You're spending a whole lot of time not turning wrenches here. Come on. Well, I see pushback like that.
There is a little misunderstanding because people really, the important thing is that we want to be able to turn wrenches more often. And as we introduce the maintenance planning lore, that you can achieve 3.5 times or 350% more work with the same workforce if you plan the work. Mm-hmm. If we believe any part of that, and I've run experiments when I ran the planning school, took that all through Asia. we actually measured up to 11 times more productive by doing hypothetical jobs in a laboratory versus unplanned. So I believe that 3.5 times produce is the common lore, and somewhere well above 1x is where we can get to with basic maintenance planning. But precision, we want that shaft to be perfectly aligned, dead nuts, 0, ideally, and or whatever offset it needs to be for thermal growth and any other unique characteristic that particular application has. And from a coupling perspective, we want to know exactly what bolt, what socket, what hex head key fits into the coupling in order to tighten up the shells or whatever else is needed. We want to make sure that every technician has the opportunity to do the job the same way, the same time. And from a lean perspective, we want to avoid waste. And that's where the efficiency part of planning comes in. But from a precision perspective, we can't expect every technician to know everything about every part in the factory. An average factory has 30,000 different parts in the storeroom. It's impossible.
Well, I'm thinking another one of those shiny objects, Phil, is the augmented reality goggles. So that I still haven't figured out how useful that would actually be. But the idea, though, is that you write it all down, and I can hear that ops manager again going, well, wait a second. If we have to do all of these things to get it perfectly aligned or as close as we possibly can, that takes time. But
a little bit.
But I suppose, and I suspect that the payback, though, is in the ops manager's benefit, is that equipment won't wear as fast. That equipment won't cause product quality issues. That equipment motor and alignment will not go down near as often, if ever, kind of thing. It's the precision part if you get it right, it'll behave and serve you well. Where if you don't, you'll be back out there 2 weeks from now changing some bearings or something. And that argument I found in many organizations is really tough. It's the ops managers just get it done, get it running, and so on. So I think in order to implement either of these hyper precision systems or approaches, is you really need the buy-in from the senior staff that's controlling the resources.
Well, there is a disconnect, and certainly if you're in a reactive environment, there are the obvious production pressures, and operations management are incentivized on the amount of product that they produce. Not often are they always incentivized correctly on the amount of first pass quality that they produce in any given shift, but their drive and motivation and incentives are all geared at keeping the unit running and generating, hopefully, presumably, revenue. The aspects of precision maintenance are arguably you'd like to not have to do them during a reactive environment. But if you are a reactive organization, the fact is that you're going to have to do them during a reactive environment. And by doing them, you are setting the pathway to get out of that reactiveness, because every shaft that you align with precision is going to run probably 5 years without a problem. And so
it just starts chipping away and creating space for you to enjoy it.
Don't have to worry about it, right? Get the lubrication right, get all your fasteners tight and down to their appropriate torque with a locking device, and get all your shafts aligned. Those three fundamentals get you out of basic reactive mode, and all of these things begin to get better and better.
Well, there's another part to this, though, isn't there, Philip? Isn't the kitting part? When you talked about lean, if the kit in the toolbox that the technician takes out to that motor doesn't have the torque wrench, he's got to make another trip back to the tool bin.
Exactly, and that underscores the importance of writing it down, because that serves as a checklist for all the things that we need. But ideally, in my past practice, we would actually kit up the entire kit and provide all of the tools in the kit because we couldn't guarantee that our technician had the right tool in order to do the job. Now that infers a level of planning that goes beyond what we're normally used to. And if we were going to proactively plan 80% of the work so that 20% is reactive, which is another lore topic, that we've heard before. The average technician in industry, couldn't get that out, sorry, does about 2 jobs a day. And so if we've got 100 technicians, that's 200 jobs a day that we want to be 80% proactive, or 160 jobs to plan. And what we learned I learned from my tenure at NASA was that the average time to plan a job in a reactive environment is about 90 minutes. And we can get that down to about 20 minutes, including closing and opening and closing the work order, confirming all of our time, if we employ high precision planning and high precision maintenance topics. And the idea, I think Doc Palmer from the U.S. is pretty legendary for his professing the attributes of planning and scheduling systems. Yep. He made a comment at a conference many years ago that I just latched on and I really love. He says he tells his planners that they have a license for bad planning. And what does that mean? Well, because we need 160 jobs planned a day, we can't plan all of them. And even if we plan on a job, we may not get it perfect. And so the concept or notion that bad planning or less than perfected planning is something that we need to shift and begin to believe, because the idea is that we plan it incrementally. We're actually over 18 months going to get most of the plans written that are repetitive and frequent, that we're actually having problems with in the workplace. Mm-hmm. And so if we chip away at it this way, and what I've found in practice is that the average plan becomes a very good plan and kittable after it's been worked perhaps 4 or 5 times. And so Doc's mentality, I think, is spot on, that bad planning means that I can start out with a plan that's only 20%. Whatever the parts were, whatever the tools were, whatever I can capture, and I put that to bed, whether it's in an Excel sheet or in a black book or in my CMMS system somewhere in a job plan, however I want to do it, it's saved. And then the next time I go change that motor, I learn from that event and I plan a little bit more. What are the sockets that I needed? What were the torques that I needed? What was the precision that I needed for that particular style of coupling that was acceptable? And I add that to the plan and I get it a little bit more precise. And when we take HPP on steroids in the lean environment, that implies doing audits. And that's a really interesting, fun thing. And you might ask, well, how do I do a planning audit or an audit of the maintenance performance of a particular job? And the answer is it's actually very simple. You go out and observe the job and you draw in your mind perhaps an imaginary circle at about 10 meters or 30 feet around the center of that particular job. And anytime somebody leaves that circle, other than to go to a bathroom or a smoke break or for lunch, that's an audit finding, because that is why they left the circle. What tools were we missing? What parts were we missing? What bolts were we missing? What was the information that we didn't have? The grease that we needed for the coupling, the shims for underneath the feet, all those different things improve the plan so that the next time that we go do that job, we do it with much less variation and achieve a much higher level of precision more often. And that's how we chip away at the precision aspects and interface that with our quality management system to ensure that we are, in fact, doing everything that we say that we should do.
Yeah. Now, I imagine that from a technician's point of view, if I've got, a clear, I see one potential issue, but it's, I think, overridden by, I got everything I need. I know what I need to do. I can get it done and I can get on to the next one. And I'm the better technicians I've run into and inherently think if I do a good job, I don't have to fix this again tomorrow.
Mm.
It's kind of that thought. My job is to get it up and running to the best of my ability. And when they have a good plan and a good kit, that just makes it so much easier. They're not scrounging around in a pile of bolts looking for the particular one they need for the job. It's in the box. It's on the pallet. It's ready to go. That just allows them to do what they're there to do more often and more efficiently. The one technician I ran into said, the part of this job I like the most is when it's a troubleshooting one. There's no kit. I might have some sensors or meters or whatever, but I'm out to figure out why is this equipment not, it was an escalator in particular he was working on. It was, why is it not working? And it's going through diagnostics and stuff like that. He says it allows me to use my knowledge in a creative way to, suss out the problem. Now, when it comes to that, I need to change this motor out, or I need to change this, interface, or this circuit system needs to be replaced or whatever, then I need a good kit and procedure and all the tools are there. But he certainly enjoyed the non-repetitive part. So I think there's a role there, but I imagine even troubleshooting is a process that can be honed and made efficient. But the long-term part of this, I think, from a technician's point of view, is it lets them do what they're good at in an efficient way. And I would suspect leads to job satisfaction, has payoffs in reducing turnover. And when it's really working, is they're doing the audit themselves. Hey, look, I was missing this part from the plan. I needed to go back and get this other tool. They're updating it. You don't need to audit it. I would suspect that would be a signal that it's working.
Yeah, you're right on target there. And what I've seen in practice, and I'll just go back in my journey. We had a particular outage that we prepared for 3 or 4 months ahead of time. We're going to take a unit down that was a critical bottleneck. We couldn't produce any product for a period of time while this unit was down. And we're going to do it this particular summer year in a 3-day outage instead of a 10-day outage. So we prepared kits for 117 jobs. Typically, across the 10 days in the past, historically, they would get about 30 jobs done. And what we found was with all these kits positioned out around the machine is that the pride and joy that the technicians had, they actually worked through lunch and afternoon meals several times to just jump onto the next job without being asked, because everything was there for them to be successful, to do the job perfectly with precision. And when the unit 3 days later was scheduled to start up, it started up at a performance level that had never been observed in the factory, because everything had been maintained so precisely. So there is an absolute joy factor in having and to be able to do a good job and to be able to go to work and do what you're supposed to be able to do without all the problems and delays and searching for parts and those aspects. And I think hypothetically, if we look at that more holistically, when we're in a very reactive environment without significant planning, let alone precision planning, leading to precision maintenance concepts on the peak of our maturity growth, even basic planning, the likelihood that we will suppress any failure mode on a piece of equipment is low. Yep. Even when we're doing PMs and inspections, it's low. Yep. And what we're introducing with the concept of high precision planning and high precision maintenance is that's the pinnacle of the journey. And we may not be able to achieve that right away, but by introducing those concepts and starting the journey towards those concepts, we immediately begin the journey where we improve the probability that failure modes are being suppressed with our PM strategy, our inspection-based, condition-based strategies, and all of the different repairs that we're making. They're going to stay repaired for probably about 5 years. Whereas before, if we put a new motor in or on a misaligned pump, we might get 3 or 6 months out of it before we wipe out the bearing, either on the pump or the seal or the motor.
Mm-hmm.
And as a result, it's that incremental chipping away with the precision and perfection that we are suppressing and keeping the failure modes under control with the aspects of precision maintenance. And by doing the audit, when we add the audit on top of all of that, we hold ourselves accountable, and we open up the opportunity for an intensely intimate learning opportunity where we actually get the opportunity to achieve perfection right in front of us. And if we take advantage of that, that's really good. And the organizations or the industry, I won't name them because there's only a few people that are actually practicing this today. But the organization that is practicing that claims that they get 250% improvements in first-time quality off of their assets when they introduce the high precision planning and high precision maintenance program to the factory over traditional planning and scheduling. And they get a improvement in productivity as well. So it's a double bang. It's a double win. And just by doing things a little bit better, making sure that all the parts are there, when we have conscientious people that care about the job, we're setting the stage for win. And we're setting the stage that failure mode that we talk about so often in reliability, that gets suppressed effectively. And it's very, very important for an organization to become first quartile performance. You have to have the concepts, whether you call it HPP or HPM, but you have to have those on the maintenance execution side, and you have to have it coupled with a very good strategic view of when to do your time-based maintenance and inspections of condition.
Yeah, yeah. I'm not going to ask the question, but I think it's going to be a topic for another podcast. It has something to do with reliability-centered maintenance and that whole bailiwick. But I have no idea where that will go, so I'm not going to ask that. But I'm glad. I think I intuitively got that. I didn't know that name. But if you're well prepared and your team's got what they need to do what they do, that's a good thing. And then adding the precision part, that was new to me. The hyper precision piece in the alignment is an example of that. It's just, I get that. It goes beyond just inspect. It gets like, let's get it as close as we can and continue to improve it. And even the transition piece of that just all makes sense. It makes me wonder why there's not more people doing this, but there's a lot of questions I have, all kinds of processes. But if you're listening to this and going, oh, I never heard of that, or, oh yeah, we do that. Is it working for you? Are you making progress? Are you moving closer to the goal of, having all this benefit out of it? Or what do you see as the hurdles or barriers to it? Maybe I didn't ask the right question or bring up the right example. Let us know. Let us bring it into the discussion, and we'll get Philip back on the line, and we'll talk through it some more. And a couple of the other hosts, I'm sure, can chime in on it. But as you know, in most of my podcasts, or in this show anyway, we always ask if you've got a question or if you have a comment on this particular episode or any of them, let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. And then you can also find Philip and I and the other hosts of the show on LinkedIn and on our About pages on Accendo. So plenty of ways for you to get in touch. And we sincerely look forward to hearing from you. We really do enjoy it. I think, Philip, I think in the last 10 episodes, these two came out of discussions and questions I had for you. What's going on and what is that kind of thing. But the other 8 were questions from listeners. So, I'm liking in the recent round of recording we've done that we've had a good number of really good questions to talk about. So hopefully we'll flush that out some more and get some more questions going for us in the future. So once again, Philip, enjoyed it. I got to learn a little bit about the something I really didn't know the acronym for. So I appreciate that.
It's my pleasure, Fred. HPP, HPM are very important topics for us to consider in just about every industry. There's application towards the journey towards excellence as we try to move forward and achieve first quartile performance. The challenge is that we need to do certain things in order to get there. We need to understand why they're important. And it's a pleasure to join you.
All right. Well, thanks, Philip. We'll talk again soon. And I hope it's sooner than it's been a while since we've chatted. So hopefully we get you on the schedule and on a routine basis.
All right. Love to.
All right. Great. Well, talk to you later, Philip. Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.